Hello, my dear students, and welcome in the Indoor Environmental Control course. I am Associate Professor Kareem Galal.
This time I will continue with the lighting section, Design Methods. The title of this lecture is Daylight Factor Method. It has been observed that although overcast sky illuminance may vary between quite wide limits, the ratio between illuminance at a point indoors to that outdoors remains constant. This ratio is the DF expressed as a percentage. The EI is the indoor illuminance at a certain point, and O is the outdoor illuminance at the window. But EI is not always available, and there is another accurate method based on three factors SC, ERC, and IRC. Daylight can reach a point of the work plane by three routes, thus three components of DF are distinguished. SC, the sky component, light from a patch of sky visible from the point considered. ERC, the externally reflected component, light reflected by outdoor objects, for example, other buildings. IRC, the internally reflected component, any light entering the window, but not reaching the work plane directly, only after reflections by internal surfaces, notably the ceiling. The DF factor calculates using the following formula. But how can we calculate each factor? We can start with SC factor. First, we should use the BRS daylight factor protractor. The above section helps to calculate the sky component for long windows % using the aperture section. Draw room section. Locate the working plane level and the selective point O. Draw PO line and row line. Measure the outer scale between PO and row lines. 5.0 to 0.4 equals 4.6. This value is the SC without the window's width factor. Measure the inner scale between PO and row lines. 30-5 equals 25. This value is the angle of elevation. Next, draw room plan. Locate the selective point O. Draw line MO. Draw line NO. Draw a half-circle line to locate the angle of elevation 25. Calculate the blue point value by locating it between the two blue lines. 0.1 and 0.2 equals 0.15. Calculate the green point value by locating it between the two green lines. 0.4 and 0.3 equals 0.35. It is led to 0.15 plus 0.35 equals 0.50, which is the correction factor to the relation of the window's width and the window's height. Then the SC equals 4.6 times 0.5 equals 2.3%. The same method should use to calculate the ERC value. But the IRC should use another type of chart. Use of the IRC nomogram and the wall reflectance table %. To calculate it, let S take an example. Assume a room 5 times 4 times 2.7 meters, with one window of 2.5 times 1.5 meters, and row walls equals 0.3 wall reflectance factor. First, calculate the total surface area, which contains the ceiling and floor areas. 5 times 4 times 2 equals 40 square meters. The long side walls areas. 5 times 2, 7 times 2 equals 27 square meters. The short side walls areas. 4 times 2, 7 times 2 equals 21.6 square meters. So the total surface area equals 88.6 square meters. And the wall surface area equals 48.6 square meters. The ratio between wall surface area and total surface area is 48.6, 86.6 equals 0.5612. Then calculate the window area. 2.5 times 1.5 equals 3.75 square meters. Thus the opening area to the total surface area ratio is 3.75, 88.6 equals 0.042. If row walls equals 0.3, from table of, the average from table will be 0.35, 35%. This defines redline 1 showing an IRC of 0.55%. If the altitude of obstruction is 15, this gives blue line 2 and the corrected IRC is 0.5%. Thanks for following me, and I hope that I have explained the topic well.
This material is copyrighted Associate Professor Kareem Galal 2021. All rights reserved.